Hello guys, welcome back to this works. Let's solve today's POTD. So today's POTD is a classical problem that is nothing but VFOs of graph. So we are given one first thing is connected undirected graph represented by 2D adjacent list and where each ADJ of I represents the list of vertices connected to vertex I. We have to perform the breadth first search VFS traversal starting from index 0. Okay, and let's take this example and first explain like how the VFS works. Okay, so let me take the input from here. So first it is given, first thing it was given that it is a undirected undirected graph. Okay, so how undirected, what undirected means? So suppose if you take this, the, there is this is one thing and this is another thing. So this is called directed because, and this is called undirected. And for one thing is, if you find the video useful, please subscribe my channel. I have very low subscribers. So if there is an arrow from one node to another node, this is called directed. It means you can go from this to this but cannot go back. Okay, so this is in this is also there, and this is also there, and this is also there. So this is called undirected, means no direction. It is in directed means there is direction only 1 to 2. Okay, so we are given undirected, that means there is no directions. Okay, also it is undirected. Connect what, and another term is connected. So you should understand the meaning of this. Connected means 1 2 3 4. Connect, what connected means? Connected means if you start from any node, you can travel to any node in the graph. But here if you see, if you start from 1, can you go to? Yes, you can go to 2, you can go to 3, but can you go to 4? No. So it means it's not connected. Connected means if you start from any node in the graph, you can go to any node, from any node to any node. Okay, so suppose this is this way. If you start from any node, suppose you start from this node, you can go there, you can go here, you can go here, you can go here. So this means it is a connected graph. Okay, okay, now we have to do the VFS. Suppose the graph is like this. So how will you perform VFS? It is not mentioned now, which node will you take first, so you will get confused. So that's why it is given connected in the question. Okay, suppose this is your graph. This is node 0 1 4 3 2. These are number of nodes. Okay, suppose this is a node. So what BFS do is, in BFS we traverse by level. If we first we will, it is level 1, so we will take our answer will be contain 0. Then once level 1, it's come 3 node 1 4 3 2 1 4 1 4 3, and it will be left to right. Okay, and next level it is coming 2. So our answer will be 0 1 4 3 2. This will be our answer. So we have to find this one. Okay, for graph, given graph. Okay, so you know how this is working in the simple terms. Now in code we will look. Okay, this is a simple way. So now VFS, we will do the VFS. Okay, so I'm making the graph here. 1, sorry, 0. We will start from 0 every time. 1 2, and I am writing here 4, and writing here 5, and suppose here is 3. Okay, so what we have to do, we have to process this first, and then all nodes that are connected to this 0. Okay, so there is one simple thing that you can remember is, you you have to use the queue. What you will do, you will insert this 0 first. Suppose this is your queue. You know queue, how queue works. We first come first serve. First come first serve, you know, like 0 is pushing here. Suppose 0 is here, now we push the 0. Now after pushing the 0, we also in answer variable we also mark the 0. Now we we push the whole neighbor of 0 into the queue. We will take this 0 out, we will remove this 0, and we will push the whole neighbors. What are the neighbors of 0? 1, 2, 4. Okay, left to right order. Okay, left to right order we have pushed all the neighbors. Okay, now again we will check the queue, first element of queue. What is the first element of queue? That is nothing but 1. So now we will check the all neighbors of 1. Neighbors of 1, what are the neighbors of 1? Neighbors of 1 is only 0, that we have already processed, so nothing to do with this. So now we can remove this 0, remove this 1. Okay, now we have removed this. Now what comes here? 2 is coming here. What are the neighbors of 2? Neighbors of 2 is 3 and 0. 0 we have already processed, so what remains? 3. We will push this 3, and now we have done with this 2, so we will remove this 2. Okay, now what is coming? Okay, we have processed 1 and 2 also, so anything get processed we will mark here 0 and 2. Okay, now comes 4. What are the numbers of 4? 5 and 0. We have processed 0. Now remaining is 5. So there will be 5 here. Now we have done with 4. So we can process it here. We can write it here. Now what is coming? Coming is 3. What is the neighbor of 3? 2. 2 we have processed. 2. There will be 3 here. Now again what is remaining? 5. Neighbor of 5 is 4. That is we have already processed. So it will here it will come 5. So nothing is left in the queue, and this is our answer. Okay, so if you see like why we are using queue, why? So this is a simple graph. Suppose, but there are edge like this also is there. Suppose if edge is like this also there, so you will get confused. Like you pushed 1, 2, and 4. Like you pushed 4 neighbor of 0. You pushed 0 and 2, 4. Now if you, for you neighbor of 1, you came here and you see there is 3. So you pushed this 3 and you removed this 0. Now if you now you come at this 2, you will see neighbor of 0 done. Neighbor of 2 is 3 is also there. So you will push this 3 twice. Okay. Okay. First time we will push this 3 twice. Okay. So there is no problem. Okay. Now we came to 4. Neighbor of 4 is 5. Okay, so we have write it 5. So this is done, this is done. So now this 3 will come. Now this 3 will come. So what we will do? 3 neighbor of 3 is 1 and 2. That is already done. So nothing to do with this. Now we remove this 3 and we mark like 3 is processed. So now whenever again 3 will come, we will say it is processed and not need to process. Okay. So this way, if these connected edges and loops are there, this will be work. So now come to the coding part. So for processed, I am writing a array. I am making a visited array. It if visited even it means it's processed, otherwise it's not processed. Okay. Now let's come to the coding part. How I have coded this. It's good. It's a like it's a very standard problem. So you should learn this, and you can like you can easily remember like you have to use the queue. If there are weighted edges, you have to use priority queue. Okay. If there are 0, 1 edges, you have to use DQ. So these are kind of classical things that you can remember. Okay. So what I have done, this is our answer array. I have declared we will push everything into the answer at the end we want answer. Visited array, I have already mentioned what is visited. Visited means processed or not. Okay. So this is 0, 2, 1, 3, and this 4. Okay. So this is visited. Initially all, not nothing is visited, so all will be, this is red is 0 visited. So this is visited, that is 0 initially for all nodes. Okay. Now this is q. As it been mentioned in the question, we have to start with 0. So I have in the q, this is our q, I have pushed 0. Okay. So now until or unless this queue is empty, we will do this again and again. What we will do? We will take the first element of the queue. Okay, and we will remove this. We will take this q. Current is now 0. This is current. I have assigned this current. Okay. So if current is visited, we continue. Like we have, if we have done processing with current, this we will not do anything. But as of now, this is 0. So we haven't done processing of this process. So this is not 1. So now we will assign this to 1 and push in the answer. So over 0 will be here in the answer, and now we will mark this as 1. Now processing of this is done. And what we will do, we will push the all neighbors. Now what are the neighbor of 0? That is nothing but 2, 1 and 3. Okay. Now again come. What is the first element? That is 2. So now current will be 2. We remove this 2. Okay. Now it 2 is visited or not? It's not visited. So we will mark this with visited. And what we will do? We will push the all neighbors. What are the neighbors of 2? Now you will neighbors of 2 will be 0 and 1. 0 is 0. Neighbors of 2 is 0. Yeah, we know we have nothing to do with this, but neighbor of 2 is 0. This is how actually process working. Okay. Now again will come, what is the first element of Q? That is 1. So now current is become 1. Okay. Now current is become 1, and now we remove this 1, and okay, we have to push here. Current we have didn't push. So now this is current is 1. Current is not visited because there is 0. Okay, it's not visited. We will mark this visited and we will push this into the answer. Okay, and now what we will do? We will push the all neighbors of 1. What are the neighbors of 1? Neighbors of 1 is nothing but 0 only here. Okay, so this is done. Now you again come, what is the first element in the queue? That is 3. So now current will become 3. 3 is visited or not? 3 is not visited. So we will mark this visited. We will push this into the answer. Okay. Now we will push the all neighbors of 3. What are the neighbors of 3? Is nothing but 0 and 4. So I have pushed 0 and 4. Okay. So I am writing this here again. 3, 0, 0, 0, 4. Now we have done with 3. Okay. So now what is coming here? Next 0. So current is 0. Okay. We remove this. Remove this. Pop. Current is 0. Okay. So now what we'll do? If visited, continue. 0 is visited or not? 0 is visited. Here is 1. 0 is visited means we have nothing to do, and we will go to the next, like we will continue the next step. So this is now we are continuing the next step, and now current is this 0. This 0 is removed. Now current is this 0. Again this 0 is visited. Remove this and go to next step. Come here again, this 0 is visited, nothing to do. Now we came to 4. 4 is visited or not? 4 is not visited. We will mark this visited. We will push this 4 into the answer. Okay, we will push, and now this is removed here from here. We will push this neighbors, that is nothing but, what is the neighbor of 4? Neighbor of 4 is 3. So we push this neighbor 3. Now we again come, there is only 3 remaining. So current will be 3. We remove this 3 from here. Current is 3. 3 is visited or not? 3 is visited. 3 is visited, nothing to do. And now there is nothing remaining in the queue. So we process is done. And this is our answer. That is 0, 2, 1, 3, 4. 0, 2, 1, 3, 2, 1, 3, and 4. This is working. If you talk about time complexity, it is, you can directly remember order V plus E. E is the number of edges and it is the number of nodes, because from each node we are processing all edges. Okay, because we are processing all the nodes and all the edges. This is the time complexity. Okay, and space complexity, if you talk about, this is nothing but order V, because it can be order V plus. It is order V plus. Why not V? Because if you see, we are pushing a single node multiple times, and how many times it can be? It can be E times. Mostly it can be E times. Okay, because how many edges it have depends on that. So space complexity will also be order V plus E. Thank you for watching the video. If you find the video solution useful, please subscribe my channel and share with others. Thank you.